Okay, so today we're going to start talking about solving logarithmic equations. And there are so many different methods we can use. But one of the things I really want you to think about, the domain, okay, that's super sloppy. The domain x has to be greater than 0 for logarithms. Okay, we can only take logarithms of positive numbers, just something to kind of throw back into your brain. All right, so this first example is just kind of like expanding the equation using log base 10. So we're going to take the log of both sides, just like you can add 2 to both sides or divide by 2 both sides. You can take the log of both sides. The log has to go in the very front. Don't ever put it behind. It always needs to go in the front of each side. Okay. Now, since these are two different bases, we can separate this. This just has one base, so this side is done. And since this one has two different bases, I'm going to expand, giving each one its own log. Since these are being multiplied, I'm going to add the logs. Then I go back, I'm going to look for any exponents through the equation, which this one has an exponent, and I'm going to move it to the front. So IB just kind of takes this in stages. So that's a B. So it's just kind of taking you through the process kind of slow. So that's okay. All right, so this side, we're going to take log of P equals log of 20 divided by the square root of n. Now, this has two different bases on this side. Log base P is fine, but I'm going to give each one its own log. Since I'm dividing, I'm going to subtract the logs, and I'm going to rewrite the square root of n as n to the 1/2 power, because this then allows me to move the half to the front. So that's one thing you really want to be comfortable with. If it's in the front, you might need to move it to the back. If it's an exponent, you might want to move it to the front. All right, now we're just going to go backwards. We're going to write without logarithms. So our first goal is to write with one log on each side. So we need to condense. This side's already good to go. As I look at my right side, I'm going to look for any number that's in front. I can't condense this into one log if there's a number in front. So in this case, I'm going to move this side back to being an exponent. And since I'm adding my logs, I'm going to multiply my bases. Then as soon as I have one log on each side, think about it this way. What makes the left side equal to the right side? If everything on the left equals everything on the right. So as soon as the logs are the same, what makes A equal BC squared? And this is my final answer. This equation is just like this one, because log of this will equal log of this. So A must equal BC squared. All right, same thing over here. I need to condense. So my left side is already done. This needs to move back to being an exponent. The problem is this one doesn't even have a log. So I need to replace 2 with a log base 2. So let's think about what we need to do here. 2 equals log base 2, because remember, the first thing I need to do is match it to whatever this log is. Then this base has to match this base. I don't like this because there's way too many 2's. So these have to match, and this goes into the exponent. So because this is base 2, this needs to be base 2. Then I need to match my bases. So these both are 2's, and this moves back to being to exponent, and 2 squared is 4. Okay, now I can condense. So I have 2 logs and I'm subtracting, so I can condense into 1 log base 2 and divide the bases. A to the third divided by 4. And as soon as I have log base 2 on both sides, the log base 2's are already equal. I just need to decide what makes m equal a to the fourth or a to the third over 4. And I've taken the logs completely out. These are both equivalent equations here. Okay. Now I added an extra example with this because I noticed that the book actually has you solve some stuff but didn't give you an example. So I want to come back to this. So this is very similar. We're going to condense 2 logs into 1. Since I'm adding the logs, I'm going to multiply the bases. And I have 1 log on this side and not on this side. You can do this a couple of ways. We can replace this just like we were doing before, which would look like what? Log, I'm going to go ahead and distribute. That'll be 5x squared minus 5x equals, this is base 10, right? And if this is base 10, that means this is 10 to the power of 2. And as soon as the logs are the same on each side, we just set the quantities equal to each other, and 10 squared is 100. Now, if you don't like this method, you can always cancel the log out using powers. So I'm going to raise each side 10 to the power of each side because logs and exponentials are inverses. So this 10 cancels out this log base 10. I'm going to go ahead and distribute. And this is 10 squared, which is 100. Notice both of these exactly the same. So you need to decide, do you like raising both sides to the power of 10, or do you like replacing 2 with a logarithm and then setting them equal? Because they both give you the same thing. All right, now to solve this is a quadratic. I'll just use this, has more room. How do you solve any quadratic equation? We want to set it equal to 0. So I'm going to move my 100 over. I notice now quadratics, I always try to factor first. Because half your IB test is going to be non-calculator, more than likely you're going to have to factor if it's a quadratic. But I also notice there's a GCF of 5. So I'm going to go ahead and factor out the 5. And then I can factor what's left. So I need factors of 20 that subtract to get 1. So I need minus 5 plus 4. So x equals 5, x equals negative 4 are my 2 answers to the quadratic. But let's remember what I was talking about earlier. The domain, x's got to be greater than 0. Now be careful. With the domain of the logarithms has to be greater than 0. Not this. I'm not talking about this x. I'm talking about the domain of x. What that means is when I plug my numbers back in, back up here to check my equation, if I plug 5 in, does this number cause me to take the log of a negative? 5 times 5 is 25. Nope. 5 minus 4, that's log of 4. Nope. So this is an okay answer. Notice though, when I plug in negative 4, that makes me take log of negative 20. Now, just try it. Plug it into your calculator. Log negative 20 and it gives you an error as an answer. That's because the domain, you can't take log of negative numbers. It must be a number greater than 0. So this is what we call an extraneous solution because it causes us to take the log of a negative. This is the only, well, this is an answer that makes this equation work, but it doesn't make the original equation work. We call that extraneous. All right, so this is the only answer that makes the original equation work. So that's the only one we need.